Hello everybody, today we will be going over a linear equations problem at the IB Math AISL level. So we have the equation of a line L1 is this, right? Y minus 3x plus 5 equals 0. And for the line L1 we need to find the x-intercept and the gradient. See? So first things first, usually when you get your equation like this, you want to turn it into the linear equation sort of like form. Now there's three forms that exist. We have the point slope form, which is top left. We have the linear equation, which is the one in the middle, and the standard form, the one on the right. This time we got it in standard form. See? Usually we want to put it in the linear equation form because it's much easier to interpret. The linear equation form is something much more friendly that you've probably seen before. And here, there's a couple of things that we know. We know that this is slope, the m, right, which is synonym for gradient. And we also have that this b is the y-intercept. See? And so usually you want to take it to this form because it's just easier to work with. See? And so, that being said, let's take it into that form. So y minus 3x plus 5 equals 0. We want to get y alone, so I'm going to do 3x to both sides, plus 3x, sorry. So we're going to end up with y plus 5 equals 3x. Now I'm going to do minus 5, y equals 3x minus 5. See? So now we got it into the linear equation form. It's much easier to interpret, and we will work from here. See? So for the x-intercept, let's remember that the x-intercept is somewhere along this line. See? Now my question to you is, all of these points that are in red, see, what do they all have in common? Of course, they are all the x-intercept. And what do all x-intercepts have in common? Well, their y value is 0. Your x-intercept always has this form. So I'm going to plug this in over here and see what we get. So my y is going to be 0 equals 3 times x minus 5. See? I want to get x alone, so I'm going to do 5 to the other side, plus 5. 5 equals 3x. X equals 5 over 3. This point is over there. My x-intercept is on the point 5/3, comma, 0. See? So that is part A. Part I, for the gradient, we already put it into the linear equation form, so we can just look at this number here. It's a 3. The gradient is 3, or we can also get ourselves fancy and say that m equals 3. See? All right, so that is for part A. For the second part, part B, they tell us that a second line L2 intersects the y-axis at this point here and is parallel to L1. So we need to find the equation of L2 and give our answer in the form y equals mx plus c. I put it as plus b, but honestly, it's the same thing. See? They're synonyms. All right, so anytime you want to create a line, there's a couple ways to do it. See? There's some fast ways, some slower ways, and I'm going to give you a way that always, 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 always works. See? So although you might take a couple extra steps, it is incredibly reliable and you should always use. See? This form is called the point slope form. See? It's this guy on the top left, right? So let's talk about this guy for a second. This guy has y minus y1 equals m times x minus x1. See? So what do we need? We need this, this, and this. See? This x1 and y1 is quite literally a set of points. See? So if you have a set of points, you can use this. And the m, as we saw earlier, was the slope. See? So if you have slope and a single set of points, you can use this, right? And we will reach y equals mx plus c eventually. Okay? I will show you how. But once we identified that we have a set of points and a slope, we can use this. See? So the set of points I'm going to use is 0, 2, right? So my x1 is going to be 0. My y1 is going to be 2. Now what is my slope? Well, we know that L2 is parallel to L1. Parallel lines look like this. What do they have in common? They have the same growth rate. They have the same slope. Rule of thumb, parallel lines look like this, and they have the same slope. Nerd fact, these lines never touch because they're parallel. They grow at the same rate. They will never ever intersect. Anyways, they are parallel, and so this m is the same m that we found earlier, which we said was 3. So this is my info for L2. See, we're going to plug in all this into point slope form down here. Y minus y1 we said was 2 equals m we said was 3 parentheses x minus 0. See? So we're going to distribute on the right side first. We end up with 3 times just x, ¿cierto? So y minus 2 equals 3x. We do the 2 to the other side by plus 2. Y equals 3x plus 2. All right, this is my line L2. See? That is for part B. Part C, they tell us a third line L3 passes through the point Q3, 1 and is perpendicular to L1. So now we will have the same process as earlier. See? Just that with different information. See, and that's going to help us find the gradient and give the equation in that form, right? So again, the goal is, or the game plan, get your point slope form, you turn it into y equals mx plus b, easier to interpret, you get all the information you need, bada bing, bada boom, you're done. See? So we're going to do the exact same process, only that these values here are going to change, right? So we're now looking at L3. They tell us that L3 has a point 3, 1. So that means my x1 is 3, my y1 is 1. My m, they tell us it's perpendicular to L1. Perpendicular lines look like this. Perpendicular. See? Perpendicular lines would be something like that. Okay? And so your immediate thought is probably like, okay, they're pretty much opposites. See? The mathy way to say it is that your first slope times your second slope has to equal -1. See? All right, so let's apply that, ¿cierto? So my m1 of L1, ¿cierto? We said was 3. So 3 times m3, because we're talking about our line 3, has to equal -1. m3 has to equal -1 divided by 3. That is how you get the slope for perpendicular lines. See? You can remember this two ways, either remembering this formula here or remembering that you have to flip it and multiply by -1. So if you flip 3, you end up with 1 over 3. You multiply by -1, -1/3. See? Whatever floats your boat. See? I used to remember it by flipping and times -1. But if you want to do it the mathy way, maybe it's easier to remember. It's right there. See? Anyways, that is how you get the slope. So the slope over here is -1/3, right? So again, we have all this information, and we're just going to plug it in and see what happens. Let me make some space down here real quick. All right, we end up with y minus y1, which is 1, equals -1/3. X minus x1, we said was 3. See? All right, so I'm going to distribute first on the right side, see what happens. Y minus 1 equals -1/3 x plus 3 over 3. See? Y minus 1 equals -1/3 x plus 1. Y equals -1/3 x plus 2. I did plus 1 to both sides. See? So this guy right here is L3. All right. Now that we reach this form, it's much easier to answer what they ask us. See? For example, the gradient of L3, well, since we're looking at the linear equation form, we just have to look at what m is, right? The number next to x. The number to x is -1/3. See? So for part C, we would say m3, because of the third line, is -1/3. Now when you find the equation of L3, giving your answer in the form of that, see? Where a, b, and d is this. Okay, this right here means that a, b, and d has to be an integer, okay? An integer is going to be, oh, let me write it out for a second. This means integer, okay? And an integer, the intuition is whole numbers. Whole numbers, and I will add positive and negative, see? So you can have positive and negative numbers, but they have to be whole numbers. And that is why this fraction here of the 1/3 actually bothers us, see? So the 1/3 bothers us, and also we need to have it equal to 0. So we want to throw everything over to one side. So let me make some space here on the left. I suggest first throwing everything to one side and dealing with the fraction later. See? So that's what I'm going to do right now with L3. So I'm going to take L3 and throw it all onto the left. See? So I'm going to have y plus 1/3 x, right? Minus 2 equals 0. All I did was plus 1/3 x to get rid of this guy and minus 2. See? To both sides. All right, now I have to deal with the fraction. There's only one fraction, the fraction of 1/3. See? So how can I get rid of the fraction? Well, the denominator bothers us. See? So the quickest way is to look at the denominator and say, okay, if there's a 3 down there, I'm going to multiply everything by 3. Literally. Multiply everything by 3. So we're going to have y times 3 plus 1/3 times 3 times x minus 2 times 3. See? And the magic that occurs here is right over there, where this guy and this guy disappear, and boom, no more fraction. See? So this ends up as 3y plus x minus 6 equals 0. See? And so this have, sorry, that is part D. They have the same form. See? All right, that is how you solve this problem. A quick tip that you might have picked up on earlier is use the point slope form, okay? I'm pretty sure this is not in your formula booklet, but it's seriously worth it to learn. Again, all you need is just a set of points and a slope, and you can use it. And once you have this, you can go from this to that, and from that to that. Okay, so usually you want to jump around from the forms depending on what they're asking for, but the most useful form is the linear equation because you can quickly glimpse the slope and glimpse the y-intercept. See, it's just easier to interpret, etc. Anyways, that is my tip for today. That is the linear equation problem for today, and I'll see you around.